This is the second lesson in Chapter 12, Shaft Design. We're going to talk about power transmission of chain sprockets and flat belt pulleys. So we have our learning objectives again. Again, for the chain sprockets, we're using the same torque equation as we did in Chapter 9. This one right here, it's the same one we used for the gear equations. Now we talk about bending forces coming from a chain sprocket. First of all, we have to look at how the chain delivers power. We have a tight side and a slack side. And really what happens is that based on this angle theta, we have a force distribution that's kind of off-centered. But for our calculations in this class, we're going to kind of ignore that because we're going to assume that the angle theta is really small, therefore the error is insignificant. So what I have right here, this is equation 12.6. This is the force that's imparted from the chain sprocket drive onto the shaft. You're going to need that for calculating the forces in the second part of Chapter 12 assignment. The other thing I wanted to show you was what are the bending forces on a shaft due to a V-belt drive, and that's found in equation 12.12. Okay, and then the other thing I wanted to show you was what are the bending forces due to a flat belt drive, and that equation comes from 12.13. Okay, so let's talk about our assignment 12 for now. This was the problem statement. As you can see, last time we talked about what the power transmission was here for the gear, and we calculated the forces on the shaft. When we're talking gear drives, those forces act in two directions, in this case the horizontal and the vertical directions. And now we're talking about a chain drive here, which is going to have forces acting on the shaft in the vertical direction only. And then we're also going to talk about the flat belt pulley here, which is going to have forces acting in the vertical direction only. Okay, so for lesson 1, you work problem 12.2, finding the shaft torque and forces due to the driving gear. So your homework should look something like this, okay, where we calculated what the torque was in the shaft, and we calculated what the tangential and the radial force was. And then based on that, we started drawing our force diagrams on the last sheet of your homework. Okay, in this case, in the horizontal plane, we have the tangential force acting in the horizontal plane in this direction. In the vertical plane, we have the radial force acting in this direction here. Okay, so this is what your force diagram should have looked like after you finished the first part of the Chapter 12 assignment. Okay, for this lesson, you'll complete problem 12.12. For 12.12, the shaft also transmits torque to a 6-inch chain drive sprocket. Using the equations in the presentation, you're going to compute the shaft torque due to the chain drive and the shaft forces from the chain drive. Now, here's the other part you're going to do is power distribution. Okay, so ask yourself this question. If the shaft delivers 6 horsepower to the chain drive, to the gear drive, and the shaft delivers 4 horsepower to the chain drive, how much power does the flat belt pulley deliver to the shaft? Okay. So based on that, what I want you to do is compute the shaft torque on the flat belt pulley, coming from the flat belt pulley, and also what are the bending forces on the shaft. Okay. So by the time you did these 2 steps, that's complete 12.12, and what's on this slide here, your force diagram should look something like this. Okay, here we have the forces coming in from the flat belt pulley. Here's how we have the forces coming from the chain sprocket, and here's the radial forces from the gear, and here's the tangential forces from the gear drive. Okay, so that's going to conclude this part of the lesson. For the next part of Chapter 12, here's what I'm going to want you to do. Calculate the reaction forces at the shaft bearing locations B and E in both the horizontal and vertical directions. Then I want you to draw the shear and bending moment diagrams in both the horizontal and vertical directions. That's going to be the next part of your assignment. Thank you.